Okay, so today's session is for the the class 10 student, those who are will be preparing for the board, and this year they are going to give the board. So today's session mainly for how to reduce your revision part, right? So I will focus on the Faraday's law of electromagnetic induction and also the Lenz law. So there is a huge confusion, like these two are the coils and this is the magnet. Like when the magnet is approaching some coil, what polarity will be there, right? So this part of polarity is confusing. So before the exam, students are getting some pain. So I just want to help you on that part. First of all, I'll show you a drawing. So this drawing is done by my student Ivan. So thanks Ivan for the drawing. So if you see here, so this is a magnet, north pole and south pole, okay? And this is a coil and this is another coil. So in this coil, if you see here, there is a galvanometer connected, no source of electricity. Similarly for this coil, no source of electricity. Only difference is that, let's say the number of turn is higher in this coil than this coil, right? So when this magnet will approaching to this coil, what happen that the magnet is producing magnetic flux. So this flux will expose here. There will be change in flux. So change in flux cause electromagnetic, EMF force and electromotive force, right? And this electromotive force EMF will induce the induced current. That induced current will be inside the circuit and you will get a deflection in the galvanometer. So change in flux through the relative motion of this magnet is causing the induced EMF. Induced EMF cause induced current. Same is happened for this coil, because when this magnet is approaching to this one, so change in exposure happen in this coil. Similarly, the south pole was exposed, the magnetic field and magnetic flux was exposing in this near about coil also. So when this magnet is coming this side, there will be also change in flux. The flux will be increasing here and the flux will be decreasing here. So wherever the flux is increasing or decreasing, we will consider the change in flux. So change in flux will induce the EMF, right? The induced EMF. So induced EMF will happen both for this circuit and for this circuit, right? So here also current will be produced, okay? Now the question is that what will be the polarity in these two? Now this is north pole, so here will be the north pole. Now what is the reason for that? That I will explain here. Let's say this is a magnet and this magnet is here, okay? And let's say this is the north pole. Now what happened that when this north pole is going to approaching to this coil, right? So let's say this is a simple coil, right? The same coil I have shown you. So what happened that when this magnet is approaching to this coil, there will be change in flux. Now if this is a north pole, right? Here will be north pole. Why? Because according to Lenz law, what happened that the Lenz law told that whenever there is a change in flux and there is an induced EMF happen, so the current produced, the induced current will oppose the cause of the change, right? That means the cause is that magnet is approaching towards this coil. Now Lenz law saying that okay, so the magnetic force produced by this induced current should oppose this motion. How to oppose this motion? By creating a north pole here. That's why a north pole will be creating here. So magnet is trying to approach this side. So the Lenz law is saying that induced current will oppose the cause for which it is created. So what is the cause? The magnet is approaching toward the coil, right? Now I have to make it a repulsion. So for repulsion, this is north pole and here should be north pole. So north pole repulsion happen. So there will be repulsion, right? So this is the validation of Lenz law. Now let's say for this coil, what happened when the magnet is coming away from this coil. So if this is north pole, this is south pole. So this is south pole. When south pole is coming away from this flux, what happened? There will be a north pole, because there is an relative motion, just coming away from this coil, this one, but this coil will try to attract the magnet according to Lenz law. But Lenz law says that whenever there is relative motion, the same induced EMF will happen here to induced current. So this induced current will produce a magnetic force, and this force will try to attract this magnet according to Lenz law by creating an opposite pole here. So if this is the south pole, here will be the north pole. Here will be the north pole, right? So this way you can validate, and I believe that if you do similar kind of practice in home, definitely this will help you. Okay, keep practicing. Now one more thing that that you are getting a question like magnet is coming, if north pole is approaching towards a coil, and north pole is approaching towards a coil, right? So here will be north pole, so it will cause repulsion. Okay, this is one concept. One more concept is that whenever, forget about this the magnet now, whenever there is a current is producing in a coil, then let's say example of electromagnet. In electromagnet we know that there is a temporary magnet produced. So this coiling, see the coiling, if the coiling if here the coiling is like this, right, the anti-clockwise, so this pole will be north pole. So this pole will be, sorry, if you see this coiling here, if you see the coiling here, coiling is like clockwise, so here will be south pole. Okay, so that's it for today's. Please keep watching my session, and I believe this will be helpful for you. Thank you.